Simpson's rule, also known as Simpson's approximation, is a formula used to calculate the approximate value of a definite integral or the area under a curve. Other methods used to approximate the area under a curve are the trapezoid method and the midpoint method. The trapezoid method constructs trapezoids underneath the curve in order to best represent how the curve is shaped and represent the area underneath. However, some spaces of trapezoids cannot best fit underneath the curve, such as here and here, so this method leaves room for error. Additionally, the midpoint method could be used, where rectangles are constructed at their midpoints to meet the height of the curve, but some areas of curves cannot fit rectangles underneath them, so there is another space for error within this method as well. So Simpson's rule uses a integral from a to b at a given function and is defined as delta x over 3, where delta x is b minus a, so the upper bound of the integral minus the lower bound, over n, and n is the number of intervals within that given integral. Additionally, within this formula, n has to be an even number. So the formula is delta x over 3, and this is multiplied by the function evaluated at every number within the given interval. So if you were to have 6 intervals, you would have f of x sub 0 plus 4 f of x sub 1, 2 f of x sub 2, and so on. It repeats 4, 2, 4, 2, 4, and ends with the last interval of 1. So for a given example problem, we have an integral from 0 to 2 at the function 4 over x cubed plus 2. And on the right here is the graph of this function. So this integral would be looking for the area from 0 to 2 on the x-axis underneath the curve, which is highlighted in the red section here. In order to evaluate this function, we have delta x equals 2 minus 0, so that's b minus a here, over 4. And in this calculation, n would be equal to 4, as it was chosen and it is an even number. So our delta x would be equal to 1/2, and this would give us the beginning of our formula, 0.5 over 3 times f of x sub 0 plus the coefficients 4, 2, 4, and ending with a 1 at the last interval f of x sub 4. So for this given function, we have an interval of 0 to 2, so 4 intervals from 0 to 2 would give us x sub 0 at 0, x sub 1 at 0.5, x sub 2 at 1, x sub 3 at 1.5, and x sub 4 at 2, with 5 total values to plug into this function here. So we went ahead and plugged all these numbers in, and we would get this. We would get 0.5 over 3 plus, and this is f of x sub 0, so evaluate this function evaluated with the 0 plugged in. This is evaluated with 0.5, 1, 1.5, and 2. And in total, this would give us a result of approximately 2.5175. And what this means is that if we go back to the graph, this graph here, the area of this highlighted section would be approximately 2.5. And this seems to be pretty accurate, as this is 1 unit here, 1 squared unit here. This is almost 1, and this is almost 1. So a given area of 2.5 would be pretty accurate, as this is an approximation, but it gives us the best choice between the trapezoid method, the midpoint method, and finally Simpson's rule. And the units for this number would be in units squared. And that is the approximate area under the curve of 4 over x cubed plus 2. Thanks.